It seems logical that the integral of f of x times g of x dx would equal the integral of f of x dx times the integral of g of x dx. However, that's not true. In situations like this, you need to use integration by parts. Integration by parts is derived from the product rule, which states that the derivative of u of x times v of x equals u prime of x times v of x plus v prime of x times u of x. If we were to try to solve for u of x times v of x, we could integrate both sides of the product rule equation to get this equation. Therefore, if you were given a situation where you wanted to solve for the integral of u dv, you would just need to find u times v minus the integral of v du. Let's start with a basic example. Here you can see that inside of the integrand we have two functions being multiplied by each other. So what we're going to do is we're going to find a u and a dv term. This is because we're trying to solve this. So we're setting these equal to each other by finding a u term and a dv term. So here we're going to make our u equal to x and our dv equal to e to the x dx. Then we differentiate u to get du equals dx, and we integrate dv to get v equals e to the x. Now we plug these into our formula here, and we get u times v, or x times e to the x, minus the integral of v du, or e to the x dx. Now we can simplify and get x times e to the x minus e to the x plus c. And that's our answer. So next we're going to try to integrate x times cosine 3x dx. So just like in the last problem, we're going to set u equal to x and dv equal to the rest of the function, so cosine 3x dx. Now we integrate u to get du equals dx, and we differentiate u to get du, which is dx, and then we integrate dv to get v equals sine 3x over 3. Now we plug this back into the function of u times v minus v du, so we get x times sine 3x over 3 minus the integral of v du, sine 3x over 3 times dx. Now we simplify this and we get x sine 3x over 3 minus, and we're going to pull out this 3 to get 1/3 times sine 3x dx, and simplify this one more time to get x sine 3x over 3 minus 1/3 times negative cosine 3x over 3 plus c, which becomes x sine 3x over 3 plus 1/9 cosine 3x plus c. So next we're going to integrate the natural log of x over x to the 4th dx. As you can see, we can't solve this using regular integration or u sub, so we have to use integration by parts. We're going to start by setting our u equal to the natural log of x and our dv equal to dx over x to the 4th. Now we differentiate u to get du equals dx over x, and we integrate dv to get v equals negative x to the negative 3rd over 3. Now we're going to plug this back into our function, our original formula, to get uv minus v du. So we start with our u and our v, natural log of x, times negative x to the negative 3rd over 3, minus the integral of v du, or negative x to the negative 3 over 3, times dx over x. Now we simplify this, and we get negative natural log of x over 3x cubed and we can pull out this negative sign to get plus the integral of dx over 3x to the fourth. Now we can integrate this, and we get negative natural log of x over 3x cubed plus, pull out the 1/3, dx over x to the fourth, which is negative natural log of x over 3x cubed plus 1/3 times negative x to the negative 3 over 3 plus c. We can simplify this one last time to get negative natural log of x over 3x cubed minus 1/9 times 1 over x cubed plus c. Next, we're going to try a more complicated function that combines both integration by parts and u substitution. We're going to take the integral of arcsine of 3x dx. Here, we're going to set our u equal to arcsine of 3x. And our dv will just be dx. Then we'll get v equals x, and du equals 1 over the square root of 1 minus the quantity 3x squared times 3 by the chain rule times dx. Plugging that back into our formula, we get u times v, or x arcsine 3x, minus the integral of v du, which would be 3x dx over the square root of 1 minus 9x squared. Now you can probably see that we're going to need u sub to simplify and then solve this integrand. So we're going to set our u equal to 1 minus 9x squared, and our du is going to be negative 18x dx. Now in order to make this look like this, we'll divide both sides by negative 6. Now plugging that back into this, we get x arcsine 3x plus 1/6 the integral of du over the square root of u. Now that simplifies to x arcsine 3x plus 1/6 times 2 times u to the 1/2 plus c. And then this, when we plug our u back in, is x arcsine 3x plus 1/3 the square root of 1 minus 9x squared plus c. For our last problem, we're going to use a definite integral in integration by parts. So here we have the function of x sine of x dx from 0 to pi. We're going to set u equal to x and dv equal to sine of x dx. Du is just dx, and v is negative cosine x. Now we plug this back into our formula, and we get x times negative cosine of x minus the integral of v du, or negative cosine x dx. Don't forget to carry your limits of integration, which are 0 and pi. Next, we can simplify this and solve this integral. So we get negative x cosine x from 0 to pi plus sine x from 0 to pi. Now all we have to do is plug in our different bounds. Then, when we simplify this, we get negative pi times negative 1 plus 0 plus 0 plus 0, which gives us an answer of pi.